Welcome to this explainer. Look around, and you'll quickly realize that artificial intelligence isn't just some far-off future concept, it's literally right here, right now. It's powering our search engines, navigating self-driving cars, and even transforming healthcare. But, there is just so much hype out there. So today, our goal is to strip all of that away and figure out what this technology actually is, without any of the complicated jargon.
So, I want to pose this fundamental question directly to you. What exactly is AI? If we look past all the sensational headlines and the sci-fi movies, how do we define it in plain language that actually makes sense for our everyday lives?
Okay, let's dive into this. Artificial intelligence is, at its core, simply the ability of a computer system to perform tasks that normally require human intelligence. Think of it kind of like a digital brain that can mimic human thought processes. We're talking about machines recognizing complex patterns, understanding language, making predictions, solving problems, or even choosing an action based on the information it has. To ground this abstract idea in reality, just look at everyday examples. Honestly, you're likely already using AI constantly. When a streaming service eerily recommends exactly what you want to watch next, that's AI. When doctors use advanced medical tools to scan X-rays, or when you ask ChatGPT to help draft a quick email, these are all systems performing tasks that, until very recently, strictly required a human brain.
Section 1. Rules versus learning patterns.
Now, what's really interesting about this slide is how it highlights the massive shift in how computers actually work. For decades, traditional computing was like following a strict recipe. A programmer wrote explicit, step-by-step instructions. If this happens, do that. It was entirely rule-based. Modern AI, however, is a lot more like a student. It doesn't get a strict rulebook. Instead, it acts as a tireless pattern recognition assistant, learning those patterns directly from vast amounts of examples and data.
So here's how that learning actually happens. Think about teaching a system the difference between a cat and a dog. You don't program a rigid rule that says, cats have pointy ears. Instead, you feed the system massive amounts of data, literally thousands of images labeled cat and dog. Over time, it learns the underlying visual features, separating them all on its own. And the exact same thing happens with language. Give a model enormous amounts of text, and it learns the intricate patterns of how words and ideas logically relate to one another.
Section 2. The three-stage AI process. Let's move to and see how this builds. When you break it all down, the way these systems operate flows through three really simple steps. Step 1. Receive data. The system takes in raw information, like text or images. Step 2. The algorithm learns patterns. It searches relentlessly through that raw data to uncover hidden connections. And Step 3, the model predicts or generates an output. The trained model uses those learned patterns to make an accurate prediction or even generate something brand new.
Applying that three-step process makes its utility incredibly clear. Take an email filter, for example. It takes in data, recognizes the subtle patterns of a scam, and predicts whether an incoming message is spam. A recommendation system learns your specific viewing habits and predicts what movie you'll want to watch tonight. Meanwhile, generative AI models learn from millions of documents, predicting what words or images should logically come next to create something entirely new.
Section 3. Major branches of AI.
Think of the AI ecosystem as a specialized team of experts. Machine learning is your broad data learner. Deep learning tackles highly complex patterns using large neural networks. Then you have specialists in human communication, natural language processing, working seamlessly with text. Computer vision is the visual expert, interpreting images and video. And finally, generative AI is the creative arm, synthesizing new text, images, or even code. And these branches aren't isolated at all. They frequently overlap to create those seamless digital experiences we rely on.
Section 4. Strengths and crucial limitations. So the crucial point is we really need a reality check on what this technology can and cannot do. What AI does remarkably well is process information at lightning speed, detect hidden patterns at an enormous scale, and support us in making much better decisions. But we've got to be absolutely clear here. AI cannot do magic. It's not automatically correct. It can easily reflect bias from its training data or produce really confident but totally inaccurate answers. And most importantly, it entirely lacks human judgment, human values, and lived experience.
Because AI lacks that lived experience, human oversight is absolutely essential. We are the ones who must define the goal. We've got to continually evaluate the results for accuracy and fairness, and ultimately, human beings are the ones who must decide exactly how this technology is deployed to solve real problems. Section 5. The human advantage. The mindset we must adopt moving forward is super clear.
We shouldn't view AI as some machine that replaces human intelligence, but rather as a really powerful tool extending what people and organizations are able to do. It is fundamentally changing how we learn skills, automate tedious work, create complex projects, and lead our teams. Understanding the foundational concepts we've covered today is the first critical step toward harnessing these systems to extend your own capabilities.
As we wrap up this explainer, I want to leave you with a question to ponder. In a world where machines can recognize patterns faster than we ever could, what uniquely human problem will you choose to solve next? Let this be your roadmap moving forward. Understand AI, apply AI, lead with AI.